Okay, so we're going to continue on in section 6B. This is the part 2 video, and we're going to do just a little bit more of 6B, and then I will complete 6B with you when we return to class. Okay, so let's start talking for just a few minutes about standard scores. The number of standard deviations a data value lies above or below a mean is called its standard score, or sometimes it's called its z-score, and it's defined by this formula. To get your z-score, or your standard score, you'll take the data value and subtract the mean, and then divide that difference by the standard deviation. If the data value that you're working with is above the mean, then you'll have a positive standard score. If it's below, you'll have a negative standard score. And just an example here, a standard score for the mean is going to be 0, because the mean is 0 deviations away from itself. The standard score of a data value 1.5 standard deviations above the mean would be 1.5. If your score is, or the standard score of your data value is 2.4 standard deviations below the mean, then you would call that a negative 2.4. So just to show you an example, if it's above, it's positive. If it's below, it's negative. All right, so we have the Stanford-Binet IQ test, which is scaled so that scores are normally distributed with a mean of 100 and a standard deviation of 15. We're going to find the standard scores for the IQ scores of 85, 100, and 125. So we're going to calculate the standard scores for these IQs by using the standard score formula, which we just saw up here, with a mean of 100 and a standard deviation of 15. Okay, so I just rewrote our formula over here. Our z, or standard score, comes from the data value minus the mean, and then we're going to divide by the standard deviation. So our standard score is for 85 is going to be found by taking the value 85 and then subtracting the mean and then dividing that by 15, because we were already told that the standard deviation is 15. So if we do 85 minus 100, we actually get negative 15, and then we're dividing that by positive 15, and that's negative 1. So we would say that the standard score for 85 is going to be negative 1. The standard score for 100 would be 100 minus 100, which is 0, and then we're going to divide that by 15, which makes 0. And the standard score for 125 would be 125 minus 100, which is 25, and divide that by 15, which gives us that 1.67. So again, we're just using the formula that we have right here. All right, on our next slide, we're going to talk for just a second about standard scores and percentiles. The percentile of a data value is the percentage of all data values in a data set that are less than or equal to it. So you're going to be filling in the blank there with the less than, but the percentile is all of the data values in the set that are less than or equal to it. It's the percentage of all of those less than or equal. And so this less than tells you that if a value lies between or a value between the percentiles will actually be called or labeled in the lower percentile, which is what is said right here. A data value that lies between two percentiles is said to lie in the lower percentile. So if it happens to lie on one of these lines that marks the separation of those percentiles, then we know that, like right here, you can see our percentiles marked here at the bottom, that we're actually going to consider it to lie into the lower one. We can convert standard scores to percentiles with computer software or a standard score table. So we're going to take a look at the next slide, and we're going to see that. You also have a standard score table that's going to be with, it's on the math chart that you already given. Okay. So here you can see, this is just an example, and it extends it through 2 slides so that you can see if the z-score or the standard score is a negative 3.5, which percentile it's going to lie in. And then I've got just a few highlighted here to show you, like if the z-score is a 0, then it lies at the 50 percentile mark, which we know that means it's actually the mean. Okay, if the z-score is a 1.5, it's going to lie at the 93.32 percentile mark, and so on. And so you can see that these are just in columns here. This like 3.5 goes with the 0.02 percentile, and here we have this column all the way down. We've got another one right here that goes all the way down. It actually extends into the second slide that you guys have here in your notes. So just make sure you understand it keeps going from right here. We have the negative 2.2, and then here's negative 2.1 right below it. You got to jump down here, then you come back up here to the top, and then you can continue reading all the way down here, and then it moves all the way up down through the slides. Okay, and that's exactly actually where we're going to stop for right now. I would like to talk to you some more about that, but we're going to do that face to face. So I just wanted you to kind of be aware of this table, and that you need to check your math chart out that you've already been given, and you'll see this table on there. We are going to be using that. All right, thank you.